Now, to the assignment. Somebody has joined. Okay, it's doctor. So back to the assignment. Now, like I said, I try to make different versions. But let's see. No, this one is the one we did without recursion. If you remember, Fibonacci series starts from 0 most of the time. It can even start from 1. Then you add these two, you get 1. You add these two, you get the next value. You add these two, you get the next value, and so on. You add that, you get the next value. So having this knowledge, you can write a function as you have it here, right? And I explained, I think about two or three classes away, that you can create an array. Joshua, what type of data is this?
We did.
What type of data is this? Line 2, I highlighted.
So I can't remember.
You can't see it?
No, I can't remember.
You can't remember? Okay, all right, don't bother. So I'm moving on. So in line 2, you are declaring a variable and you are assigning this initial array to this variable 0, 1. Then you are checking if the argument you input here is 0, then your function should return the why is it okay? Yes, so print this, then return. Return, we exit from the code, from the rest of the code. These other ones will not be executed. However, if the argument, whatever you put in there, is 1, then it's going to print this the array you assign to this variable in the first place. However, if the argument is greater than 1, that is, it is not 0, it is not 1, therefore, then you compute the rest. And this is how the rest series are computed. You take this previous one, because remember, at this point in time, your index, where's my pen? Your index is 2 at this point in time. 0 index, 1 index, and 2 index. So if you do 2 minus 1 here, this will give you fib at index position 1, which is this one, right? So 1 will be returned, then plus. Then 2 minus 2, which is 0. So fib of 0, which is this index. So 0 here will be returned, right? So the value here will be returned. Then addition 1 plus 0 is 1. So this 1 is now stored at index 2. So that is how this function prints out that series. Now, this function it's not using recursion because one, there's nowhere in this code block that this function is calling itself. So, and if the function is not calling itself, then there's no way we can talk about its argument. So now let's talk about the recursion again using the assignment. I'm trying to see where, yes, this one, yes, that's the recursion. So how do I know this is recursion? One, the function is declared fib. This is a function fib named fib. And you can see here at this point in time, this function is calling itself. Is calling itself. If you look at here, you you create a function, right? Then calls itself with a smaller input. And that is exactly what is happening here. Calls is a function calling itself with a smaller input because n minus 1 is smaller than n here. So what is happening in this code? If you look at it, it says that if your argument is checking the condition, if you remember, we have treated the if condition in many times. So it's checking this condition. If this condition is true, then it's going to enter into this code block and execute whatever is in there. If not, to come here because now else if it's going to check for another condition. Now, let's come here first. Let's say I want to check for 0. Let me even run my code first. 0. Let me copy it because I don't want to introduce node at this point in time. Let me just copy it. I'll go to the online. Yes, this one. Let me run it first. Run. It returns 0 to me, the very first one. If I say 1, it returns 0, 1. If I say 2, it should return 0, 1, 1. Now let's say I say 10. It will return 0, 1. You can see this plus this is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 8 is 13, and so on and so forth till 55. So let us go through it so that I can explain the code. Now let's scratch this first, right? When it is 0, let's say you are calling 0. It will come here. Is n greater or equal to 2? No. It will scratch this. Jump to this place. Is n equal to? Already, this is false. So the moment this is already false, it won't even bother to execute this. Why? Because it is an AND operator. So it will jump here. If n is equal to 0, which is true, and the number of the length, remember that we have the norm here. So, and the length of this array is equal to 2, which simply means that you have not done any form of manipulation to this array in this previous step here and this step here. So if that's the case, just return this array. And that is the reason why the value 0 got returned. Now, let us go again. If this is 1, it comes in here. Is 1 greater than or equal to 2? No, it scratch this. Jumps in here. Is what's it called? Is 1 equal to 2? False. So it won't bother to come here because this is an AND operator. It will scratch this. To come here. Is 1 equal to 0? False. It will scratch this to jump here, and it's going to return this array, and that is why the value 0 and 1 got returned. Is there any question? Mary?
No, sir.
Favor, did you do the assignment? I can see you are here.
Sir.
Did you do the assignment, the recursion assignment?
Yes,
No.
sir.
Oh, you did? Okay. Let me, okay, you will display your work
It
later.
worked properly.
No, there's no problem. Let me see your concept. I want to see your concept. Don't try to adjust it because already I'm treating it. So
Okay.
if I see similarity, I will know that you copied me anyway.
Okay.
So now let us go to the next one, 2. If the argument is 2 here, is n greater than or equal to 2? This is true. So it will enter into this code block, right? It will do this. Get the length of this array, which is 2. 2 minus 1 is 1. Get the length, which is 2. 2 minus 2, which is 0. So the index, what value is at index 1 here, and what value is at index 0 of norms? Index 1 is 1, and index 0 is 0. So it's going to add this operator, add additional operator. 1 plus 1 is, sorry, 1 plus 0 is 1. So it will push it to the next one, push. If you remember when we discussed array. So at this level, at this point, your norm is now having this data 0, 1, and 1. So it will come here, right? It will come here, reduce the argument. Remember, if you remember recursion, like I said, to call itself and reduce the size of the argument. So here n is 2. 2 minus 1 is 1. So it will now call itself with an argument of 1. So it will come back here with n1. It's going to check. Remember, norm is already 0, 1, 1 in the first iteration. So now n is 1 here. Is 1 greater than 2? No, false. It will scratch this. Is 1 equal to 2? No, it's false. It will scratch this. So is 1 equal to 0? No. So it will scratch this. So it just come here and return norms. And what is norm? This is norm. So you have 0, 1, 1 displayed. That is for value of 2. Let us just quickly run this value of 2 so that we can refresh our memory. You can see 0, 1, 1. So I'm going to do this, demonstrate this last iteration. So let's say this is now 4. Let me jump to 4. So n is 4, right? Is 4 greater than or equal to 2? True. It will come here. So it's going to execute 4, sorry, norms norms length, remember that the length of this is 2 minus 1, 2 minus 2. So this is 1, this is 0. So it will bring out the value at index 1 and the value at index 0. So which is 1 plus 0, 1, which is 1. 1 is now pushed into the array. So now we have norms 0, 1, and 1 right there. Now, it will now come here after executing this statement, to come to the next line. And remember, n is 4. So 4 minus 1. So it will now call itself again with a 3 arguments. So instead of 4 here, let me just clean this so that we can go over it again. So this time, n is now 3. So 3 here is 3 greater than 2. True, it will come into this place. Now it will bring out the length of this array. And remember, the array is no longer 0, 1, but rather it is 0, 1, 1. And the length is 3. So this is 3 minus 1, 3 minus 2. And this will give me 2 and 1. So we get the value as index of 2 here and the index of 1 here. And what is the value at index 2 is 1. And index 1 is 1. I will bring it here. 1 plus 1 is 2. 2 is now pushed to the end of this array. So our new array will now be 0, 1, 1, and 2. So no longer this 1. So it will now call itself again with what? 3 minus 1, which is 2. So it will call itself with what? Fib of argument 2. Let me clean one again for me to explain. So now the value of n is now what? 2 at this point. So this is 2 here. 2. Is 2 greater than or equal to 2? It is true. It will come here. It will get the length of the array, which is 1, 2, 3, 4. 4 minus 1, 4 minus 2. And this is 3. This is 2. It will now get the what? The value at that index inside the norms array to try to get it out. And what is the index of 3? This is 0, 1, 2, 3. The value there is 2. To bring out 2, then plus num2 0, 1, 2 to bring out 1, right? Then 2 plus 1 is 3. So 3 will now be pushed into the array. So now my new array is now norms 0, 1, 1, 2, and 3. And you can see that it is following the Fibonacci series. Now, it will come to itself here and call itself again. This time, 2 minus 1 is 1. So it is going to call itself again, right? Fib 1. Let me quickly clean this. Fib 1. So it will call itself Fib 1. So this is now 1. Is 1 greater than 2? False. it will scratch this. Come here, is 1 equal to 2? False. It will scratch this. Is 1 equal to 0? False. So it will scratch this, then it will now come here and print nums, which is the new, this one, this new array. This one is old. Is there any question? Is there any question?
No, sir.
No, sir.
Okay. All right. So what is the time, please? This is 8:16. Okay. So this is one way that can be the solution can be resolved. So now if I check, because I try to write different different ones, this is another way. So what I will do now is this. Because of our time, I won't go through everything, because it's still it's still calling itself somewhere. Now this is what the function defined, and it's calling itself right here. So it is still Fibonacci. Sorry, recursion. And if you look very well, you will see that n is reducing. Now, I purposely did use this kind of parameter because I intend to take you through different types of parameter in function today, because when we treated function, I left it out because there are some things that you need to be armed with so that you can understand what's this concept. So I want to ask again, is there any question before I move on? Is there any question? No
No,
question.
sir.
Okay. Now, think, let me see whether it's right here. Different. Okay, even there's still a lot to teach here. Okay. So now, when we talk of parameters, right? Parameters are the variables you use when you are declaring your function. For example, you have your function, the function name, which we can say is a variable name. Then you have your parameters. However, when the function is now being called, we do not call it parameters again. We call it what? Argument. I think by now it should have been used to that. Now, this is a type of parameter. We call it default parameter. And that is exactly what I did here. We call this kind of parameter. You will see that already I have assigned an array to this variable. So that simply means that if I do not, right, state or give this argument when I call the function, just like what I have here, you can see I only give it a single argument. But normally, I should have given it two arguments. Like maybe I have something like 6 here, for example, right? So this is a second argument which will represent this variable. But Because this is a default parameter, default in the sense that I have already assigned value to that variable. So what does that mean? It simply means that if I do not state any argument for that second parameter, this value will be used. So what am I saying? Now, I call the Fibonacci function here with a 5. This 5 is the value of n. So now it will come into this code block and check this condition. Is 5 less than 0? That is what? False. Is going to skip this because 5 is not less than 0. So it will come to this conditional statement here saying that is the result. What is the result now? The result is this array of 0. Why? Because I did not state anything here and it's done on purpose, right? Because all I want is to print 5 series of what? Of the Fibonacci series, right? So now the result here is now an array of 0. And what is the length of this array? Is 1. Let me copy this out so that I can use my pen to annotate properly. I can erase this. Don't worry, I'm going to share the code on the platform. So where's my pen? So now, so at this point, the result is what? This single array, and the length is 1. Is 1 less than 2? This is false. False. It will scratch this, move to this next statement. So it's going to come here, just like what we did in the first one. Get the length of this result, which is 1. 1 minus 1 is 0. Get the length 1 minus 2 is minus 1. So because this one is, there's nothing here, so it's going to bring out the index, right? The value here. Where I'm coming. Yes, this is length 1 and yes, this is length 1 and minus 1. Yes, this is 0. So it will push the value into the results, right? Then it will come here, come to the net, because there's no, notice there's no return keyword here. So it will go to the next line. And what is happening here is calling itself again. That is a if you remember the characteristics of what? Of recursion. You can see it here. It will call itself. It will keep calling itself. So now, at this point in time, it's going to call itself here. The second time. Remember the second time now. What is n? N is 5. So 5 minus 1 is 4. Where's my pen again? So this is now 4. But remember, now we have results here. What is the false result here? The false result is what? I think we got 0. Yeah, this array of 0. Now, it will come here, put in this array there. So it will now do, try to get the value of n here, which is 4. It's going to repeat itself until it's going to populate everything. it will populate everything just like the other one. I'm not going to go through it one after the other because of our time. So let me just run it so that you and see whether it is working. Let's say 2. So I have 0, 1, 1. That is what's it called? 0, 1, 2. So it's printing 0, 1, 1 out. If I do 10, you see it's still printing the Fibonacci series out. So now let us continue with other type of what parameter. Now we have treated the default values, right? You can see from here. Let me just copy it so that it should be clear enough. Let me copy this out and paste there. So now you can, if you look at this function grid, right? I'm assigning a value to this variable name and 18 to this variable age. So even if I do not state any argument here, you can see, look at this. I'm calling the function and there's no argument. And because there's no argument right here, it's going to use the default. So here it will now say hello guest, which is guest, hello guest. You are, then the value of age will be right in that place. So you are 18 years old. But when I now run it again here, okay, let me just run the first one. So let's see. You can see, hello guest, you are 18 because it is using the default values. So this is what we call the default parameter. Now, however, the moment I give an argument, which in this case, I'm giving Alice. This argument will be used as it will be assigned to the very first variable. And because I'm stating any other argument here, I will still have 18 assigned to this age. If I run it, you will see, hello Alice, you are 18 years old. Now, if I give it an argument there, so I've given this name an argument of Alice, and I've given this age an argument, a value of 23. So what happens? It will, when this function is called, Alice will be name will be replaced with Alice, and the age will now be 23. If I run, you will see that that is what we have there. Is there any question before I move on?
No, sir.
Good. Now there's what we call rest parameter. Rest parameter. Now, as you can see, this is a syntax, and that's the reason why I wrote out the syntax. Now, you can see 3 dots right there. Please, you have to include those dots. You can't just remove the dot and say rest parameter. That will not work because this is now appearing like a normal variable for the parameter, but those 3 dots must be there. I repeat, must be there. Now, what happens? Now, it's actually an array. Now, let me quickly, let's say you have an array of, say, 0, 1, 2, 3, right? So when you do, let's say this is results, or let me say, okay, let's say results, for example, right? And I now kind of call or declare a function like this with the rest parameter, and I call that function, right? And I pass in this this variable result in there, result with the 3 dots. Don't forget 3 dots. What happens is that instead of treating it as what? As an array, it's going to break it down as values. It's going to break it down as values. And that is what it's doing. So, and it makes it easy for you to now operate on that data structure. So let's see an example. An example will make it clear for us. So let's copy this. Let me just copy this out. Go to the online stuff and paste it there. Now look at this. A function sum is declared. What type of parameter is this? It's a rest parameter. So already I know that that must be an array. Now, I need to sound a note of warning. Let's assume that you declare, let me just quickly, because I can forget. Let's say you declare a function, say, okay, let me just call it sum again. And you want to give it multiple parameters. For example, maybe first number. Okay, let me just say number 1, then number 2. And I want to kind of indicate that if there are other numbers that you wish to put in, then I can say rest numbers. Now you can see that this is in the last position, and that is the way it should be. Now I cannot, because I'm going to, if I try it, I think I will get an error. So I cannot push this one first in my parameter. It has to be the last parameter, right, in my definition. So which simply means I can call this function even if I do not state this, my code will still run. It will still run. So remember, the rest parameter is just a pointer to an array, a collection of what? Numbers. Now, I treated, if you remember, array methods in time past. I'm pretty sure maybe some of you may not be able to remember this method again. What this method is doing is that it's going to reduce if you have so number of arguments, for example, it's going to reduce it into a single value. For example, maybe you want to add it up. So it's going to add it into a single value. Why? Just for example. So in this case now, what is happening? If you go back to the previous recordings, you will see that this variable is the one that will hold the sum, the total sum of the addition. So this other one is one going through each of these. It's like the for of loop. If you remember the for of loop, so it will go through this one after the other, and it's going to add each of them to the total, right? Most of the time, the total, when you are, because we are talking of summation here, the total is 0. A 0 value is assigned to that total. So it will come here. Let's say these are my arguments. It will come here, pick 3, assign it to this variable here. Then it will now add 3 to this, right? Now look at this value. This value is the one used to initialize this total, right? So now it will now add that 3 to 0 and reassign it back to total. What this code is doing here is this: total total plus num. So this 3 here is assigned to this, and this 0 here is assigned to this. 3 plus 0 is 3. Then 3 is assigned back to this. So in the next iteration, it will pick 4. And this time, total is what? 3. It will add 3 plus 4, right? So this is now 7. It will now reassign it back to total, and so on and so forth until the addition is done. And it will now return the summation, which is the total. That is the reduce. That is why they call it the reduce for function. So it will reduce everything inside this into a single value. It all depends on what you are doing right here. I can decide to do multiplication. I can decide to do anything right in this function. This is a function, right? So I can't remember I've taken you through callback, right? But we can still talk about that later. So, but I want you to understand that the rest parameter allows you to kind of use your pass your argument as if it is ordinary numbers. No, just like you are seeing here, I'm passing 1, 2, and 3. And if I have an array, I can easily just pass it, and exactly the same thing is going to be done, achieved rather. So I repeat, let me just clear the screen. The 0 is assigned to this total, and the first number, which is 1 in this case, is assigned here. So 1 plus 0 is 1. So 1 is assigned back to the total. Then the next one is picked, and so on and so forth. Let me just run this code so that you can see that it is a summation of 1, 2, 3, which is 6. And this is 30, 60, 100. So I should have 6 and 100 in there. Let me remove this one because that is what is giving this error. Let me run again. So I have 6 and 100. Is there any question? Is there any question? I want answers, please. Is there any question?
So can you go back to the coding?
Yes, this one.
Just want to see.
Favor, is there any question?
No, sir.
Mary, is there any question? I know it's getting tougher. And that is exactly what I've been saying all this while. The higher we are going, the tougher it becomes, because we now be dealing with a more deeper concept. So the more reason why you need to be familiar with those basic stuff so that you won't get confused when you get to the higher level or higher ground, as the case may be. Right? So Favor said no question. Mary, is there any question?
No, sir.
Okay. All right. So now I, I think it is better for me because to run through this function again is so important, because I want to end function today. I'm going to rush you. Yes, you go back and review the recording. Listen to it again and again. Now, function. This is no new thing to you. You know how to declare a function, right? You give it a name. You use a keyword function. You give it a name, all right? A variable, great. Then a parameter, as the case may be. And within this code block, right, you can now use the parameter inside your code block as the case may be here. And for you to call it, you use this operator to call the function. You just say call the variable, then with this operator right in front of it. That is purely how you declare your function. Now, when you are now trying to give it a parameter, what are parameters? These are the placeholders specified in the function definition. So they represent the values the function expect to receive when that function is called. And the argument is just the real value, the actual value that is passed into those parameters. No, those parameters, they are just variables. So they are the actual data passed into those variables for the function to use within itself. For example, look at this, right? We declare a function with these parameters. Then we say, okay, fine, return the summation of these two parameters. And here we pass the arguments 5 and 3. This 5 goes into A variable. This 3 is stored into B variable. So the value of A is 5 and the value of B is 3. 3 plus 5, 8, and 8 is returned. So I move on. Now, invocation, I've explained earlier. If you want to call it, you put the name of the function, then the bracket parentheses, then you insert the argument if there is arguments to be used. If not, you just call your function, right? You call the function. So why do we actually need function? We need it for to be reused within our program, because we can just write a code that we do a function that we do a particular thing, and then we can now be calling it everywhere within our program. And that is what the reusability is all about. Once a function is defined, it can be reused multiple times throughout your code, which saves time and reduces redundancy. Organization, yes, it helps in organizing your program, and also as a result, maintenance is easy. You can easily correct if there's anything you want to update in your function. You just go to where you declare it and change it there. Whatever thing you want to change in that function, you change it right there, and it will now be reflected automatically within your program. Because assuming you did not use function, so that means that you are going to repeat that set of programs in multiple places. And if you need to now change anything, you have to go to those number of places and change whatever you want to change there that number of times. So and that is not it's a lot of work. It is not making your program to be easily maintained. It makes it so complex. So three major things: the reusability, the organization, and the maintenance. Now we come to the types of function. What are the types of function? We have different types of function. Now we have the named function. The named function. Now, any function that you declare, where's my pen again? All the time, because I'm trying to make sure I finish by 9 o'clock latest. So if I declare my function and I say sum, right? I give it 3 parameters and within my code, and I say return A plus B plus C, right? And I close my parentheses there, call it braces there, and I call my function here sum 2, 3, 4. So this we definitely add up. This 2 plus 3, 5 plus 4, 9. So 9 will be returned to me. Now, why is it called named function? It's because we give it a name here. This is a named function. It's a named function. So most of the functions we are going to declare will be named function because we need to be able to refer to that function within our code. But we have another type, which is the anonymous. We all know what anonymous means. No name. The man or the object with no name. You can see here. This is a function, right? Function that is declared with parameters x and y, and inside that is now returning x multiplied by y. That is all. Is there any variable name here? No. And that is why we call it anonymous. Anonymous. A function without a name. Anonymous. And most of the time, we assign this to now a variable. It may be, let's say, fx, right? So it is now this fx that we will now call. We now call x, so maybe 2 and 3, for example. So we will now call this. Let me quickly demonstrate this. Let's go to the browser. Let me clear my screen first. Clear to the browser. And where is that? This, yes. So anonymous function. I say A, B, then I say just return the product of the two variables to me. So if I do this, I cannot call this. I cannot. Okay, if I try to call it, what name am I going to call? Because remember, you have to before you call anything, you have to call the variable name, then the brackets in front of it. But this one does not have name. So what am I going to call it? I don't know. So that is the reason why we have to assign it to a variable, right? So it is now this one I'm going to call, then pass my argument in there, then I can run it. I should have 30 there. Okay, it's returned. I need to print it out. Console the log. I need to print it out. So 30. Is there any question? Is there any question?
No.
Good. Mary,
Sir.
no question? Favor, no question?
No question, sir.
Okay, good. Now, arrow function. Favor, have you come across this arrow function before? Or let me say, apart from the name function, have you come across anonymous function or arrow function before? Favor.
No, sir.
Okay, good. All right, so it's good that we are treating this because I thought probably, I remember I didn't treat this in class. That is why I'm going through it again, because I talked about the named function, but not anonymous and arrow function. Now, what is an arrow function? You see, the JavaScript, right, is being regulated by what they call the ECMAScript specification. So it is that, and it's a body actually. I think it's European communication something. I can't remember. If let me see. I think it's European something. ECMA. Meaning. Let's see. Yes, European Computer Manufacturer Association. Yes. So they are the body controlling, or should I get controlling? Yes. Or maybe what's the right word? I'm trying to get the adjective to use. Um, something like something like guiding, or maybe what adjective? What's that? It's like they are the one giving the specification. They decide is a group of people, different organizations to decide the specification. So I think the last one is ECMA script 5. If I'm not mistaken, is that 5 or 6? The last one they released, I think, and they call it 2015 version. 2015 version. So it's ECMA script 6. So, and in each of these version, right, they bring out new features, right? I can't remember which version of their specification that this arrow function came out from. You know, is a feature. And how is it being done? That's the question. Now, let's go from what we know. Now, if I say function, we know that normally we can give this if a name, then we call it, right? What arrow function is doing is this. It will ignore all this, just like anonymous function, but the arrow will also ignore function. In anonymous, we still use the function, like, you know, something like this. We use the function, but without a name, right? So this is anonymous, and we assign this one to what? A variable. Now in arrow, this function is even left out. So what we have now, let me just copy this to make it faster, is something like this. Your parameter inside the braces, the brackets, then equal the arrow. This is the arrow. That is why they call it arrow function. So this one is now pointing to this code block. So when this is run, it's going to return the product of these two, whatever value that is in there. Right? Now, most of the time, we use this arrow function in what is called a callback function. We are still going to treat it, right? So, but just note the graduation. Here, a name is given. In anonymous, no name is given, but you must assign it to something. The same thing in arrow function. No name is given, function is not used, but as you assign it to a variable. But when you are using it as a callback, all this variable is not needed, which we are going to see later. So arrow function is just a more concise syntax for writing anonymous function. Case closed. Simple and straightforward. So if I go back to the code and then let me comment all this one out. So and I say let var name or function, let me just say fx. So I'm assigning this to this function. So I can easily call fx, then 2, 3. Let's see what I'm going to have here. So I'm going to print console.log that. So I should be able to find 6. Yes, 6. That is the value. Now, you will have you must have noticed that, look, there's no return here, nothing. All right, even there's no braces here. The reason is simple. If your statement is just a single statement like this, a single statement, you can remove these braces and bring it to the next line. Like you can remove this, the braces, right? So, and the moment that brace is sorry, this is what I was about to discuss. The moment that braces is removed and it's a single statement and you are just returning that statement on a single line, there's no need to include the return keyword any longer. So if I run this, I'm still going to have my 6. So I purposely move from the known to the unknown, right? Let me repeat for clarity's sake. We know that if you want to declare a function, a named function, we give it a variable name, like in this case, product. If you want to do anonymous is without a name, right? But you assign it to what? A variable, right? You assign it to a variable, then you call that variable. Similarly, anonymous. In anonymous, you don't even need this function. And sorry, arrow function. You don't need this function, then but you need your arrow key, like so. It's going to point to that. But because it is a single line statement, I don't even need the what they call the brace in there. I don't even need the return. Now, if I try to do another statement here, for example, maybe a, a times b, maybe I assigned it to another variable, say results. I'm trying to do this, then the next one, and I'm saying console the log result. This will give me an error. It will give me an error because now I have more than one statement. This one is okay. Commented out. So let me do this. I'm going to have an error. You can see it is not allowed. So, but if you want to do this, so that simply means you will use the brackets, then, so the braces rather, then close the braces. If you must have more than one line of statement, you must put back the braces. Now, if I run this now, it should give me what I expected, which is 6, because here, in fact, in this case now, I do not need to console the log already because I am not returning anything there because already I've printed it using the console.log. If I call it now, you will see the value of 6. I hope it is clear. I'm going to stop here today because it's 9 o'clock. So we are going to continue with function. I want to treat function because it is super important for you to understand function very, very well. Because when we get to a complex work, right, it is function that will be used most of the time. And it will be used in its different form. You will see at times in named form, you will see it in anonymous form or the arrow form. Is there any question? Is there any question?
No. So
Mary, is
Yeah.
there any question?
no.
No. Favor, is there any question?
No, sir.
Okay. So my assignment, I want you to create 2 functions for each type of function. That is, for this name function, write 2 different functions. You call it, and let me just annotate. I want you to write a name function to calculate area of circle. Named function to calculate area of circle and to calculate area of rectangle. So anonymous function too. I want you to write an anonymous function that we also determine the area of what you call trapezium. Yes, trapezium. Then area of circle as well. So this one arrow function, 2 functions also, but this time I want area of a square, and I want volume of cylinder. So I want you to go back to your mathematics, refresh the formulas of area of a circle, area of a rectangle, area of trapezium. Okay, okay, this one I repeated here, no problem. Then area of a square and volume of a cylinder. So I'm expecting 6 functions from you, 2 per each type of function. 2 functions for named function, 2 functions for anonymous function, and 2 functions for arrow function. Is there any question on the assignment? Is there any question on the assignment?
No,
No.
sir.
Okay. All right. So I think we can call it a day. So on Saturday, before Favor joined, I passed an information earlier on. We are rounding up this class in the next 6 weeks, latest 6 weeks, and I'm going there will be a project given. The project is to drive you because now we ought to have finished this JavaScript a long time ago. We got delayed to this level because of people missing classes, we postpone classes, and we cancel classes, and so on and so forth. And also repetition, because most students fail to review past recordings, so I have to repeat and explain topics again and over and over. So the idea is just for you to be able to grab it. Please and please, you have the recordings at your disposal. Use them, please. Use them. All right. So in the next 4 to 6 weeks, this class will be rounded up. And I'm going to trying to get a project that you are going to design. Please go and review your HTML, go and review your CSS. I know the project I'm going to give you already. Remember that GTB site? I said, no, I told you then that we are going to continue on that website. So you need to, those who are yet to do this, I think it's only Favor that submitted then, only Favor. Go and do that, design that GTB website, design a page. Then we are going to integrate JavaScript with the site so that we can add behaviors to the site, right? So thank you. We meet on Saturday.
So,
Yes.
oh, never mind. No, Favor hasn't shown her work, so.
Favor. You said favor
Oh,
what?
Simon.
I don't understand.
Never mind.
No, I mind. Say it out. What are you saying?
Favor, I thought you said that she was going to share her code.
No. She will not share our code for
I mean,
the
the
GTB.
context. I
Oh,
mean,
okay, for the last assignment.
yes.
Okay, let me just yes, thank you for reminding me. Let me pause the recording.